Honorable judges, esteemed guests, hello, my name is Chuang, and today I'm going to tell you about history and progress of snake venom research in Taiwan. And here are my motives. The first is, I was curious about the rising of snake venom because when I was young, I've been hearing a lot of information about snake venom, and they said that Chuang has one of the best history of snake venom research, and the promotes and ancestors have done great accomplishments. And second is because my dad gave me a book called The Story of Snake Venom Research in Taiwan. And it talks about the snake venom's mechanism, facts, and other information about it. And a lot of accomplishments that the ancestors did. So I was really eager to know more about it, so I chose this as my topic. And my research methods. I use thesis and literature as my reference. And here are my table of contents. First, I'll be talking about snakes, because in order to talk about snake venom, you have to first know the basics, which is snakes. And then I'll be talking about snake venom and its history. I'll be talking about facts about snakes, its information and mechanism, and also about the great accomplishments that our ancestors have done. And the third is snake venom as drugs. I'll be talking about how it can be turned for use and how it can be turned into drugs, and mechanisms also behind it too. And here are information about snakes. The first, the scientific name is Serpentes, and there are about 3,600 species in the world, and its ancestors are lizards, and they are carnivorous creatures. And there are about 600 species of snakes that are poisonous, and about 200 that are really deadly, that could cause threat to a person's life. And here are some fun facts about snakes. The first is the Titanic python. It is the biggest snake on Earth, and it is about 13 meters long. And the second is a paraffin snake. It is the smallest snake on the world, and it is about 10 centimeters long. And on the right-hand side is how snakes detect animals. You can see that there are arrows pointed to the holes on the snake, and those holes are called pit holes, which can detect the temperature around its surroundings. And so because prey and animals relieve heat, so that way snakes catch its prey easily. And next, I'll be talking about snake venom. Snake venom is composed of ciliary glands of snake, and its function is to digest the tissue of its prey and defend it against its enemies. And the mechanism behind it is that the snake venom flows from venom sac into the fangs, and then the fangs will be used to inject the poison into the prey. And the venomous snake can be turned into two categories, which are called cytotoxins. And two categories are called hemorrhagic and neurotoxin. And here are some pictures of the snake venom. You can see at the left-hand side, this is a head of a big snake, and its fangs is used to inject the poison into it. And on the right-hand side is how the basic way of extracting snake venom, which is putting the fangs on the cup and then trying to get the snake venom onto it. And here are two categories of a venomous snake. One is the hemorrhagic, and one is the neurotoxin. And here are examples of snakes of it. And now I'm going to tell about hemorrhagic snakes. It mainly inhibits the blood coagulation function of platelets, resulting in the risk of bleeding. And on our right-hand side is a green bamboo snake, and on the middle is the 100-base snake, and on our left-hand side is the turtle shell snake. And now I will be talking about neurotoxins. It causes damage to the nerve system, which could cause people who cannot control their legs or hands, and then eventually die. And on our right-hand side is the cobra snake, and on the middle is the umbrella snake. And here is the approximate timeline of the snake venom research history in Taiwan. The first is Compendio Materia Medica, and then Professor Du, and his student Professor Lee, and then until nowadays. And now we'll be talking about Compendio of Materia Medica. There are two sections that have mentioned about snakes in it. One is alcohol liquor with snakes, and one is malted snake skin. And on the right-hand top side, you can see that is the Chinese name of it. And in the middle is snakes turned into alcohol liquor. And that picture is a picture of the molten snake skin. And this is the timeline of Professor Du. I'll mention some great accomplishments that he had done. First was he was the first Taiwanese with degrees of MD and PhD. And second is he was the first Taiwanese professor of Taiwan University. Because at that time, all professors in Taiwan University were Japanese, and he was the first Taiwanese to be a professor there. And he mentioned 3 local themes: Chinese medicine, opium, and Taiwan snake venom. And you could see that Taiwan snake venom stands a big part of Taiwanese medical research. And then he passed on his research to his team members, Dr. Li Zhenyu, Ouyang Zhaohe, and Dr. Zhang Chuanzhou. And this is a timeline of Professor Li, and I'll also mention some great accomplishments of it. One is that he found out the 2 deadly neurotoxins of the umbrella snake, which will be later used on to his research. And one was he received Venom Award, the highest honor of the International Society in Toxicology. And on the top side is 2 portraits of him. And on the left hand side is a textbook he wrote, Snake Venoms, which is still now widely used by universities in the world. And on the right hand side is the award I mentioned, the Venom Award, the highest honor in toxicology studies. And nowadays, scientists have been using genetic engineering and cell culture for their recent research, and they can be used to cure fibrosis, cancer, or even diabetes. And now I'll be introducing about integrin and disintegrin. The integrin's definition is important adhesion molecule on the cell membrane and is mainly responsible for interaction between cells and extracellular matrices. And the definition of disintegrin is antagonist of the integrin protein cell membrane. It has high affinity to bind with integrin. And easy to say, integrin, when cells grow, they need oxygen and nutrients, and when they grow, they have to give the signal out. And integrin is a molecule on there where it's used to get the signals out. And this integrin here binds with the integrin, which will cause the signals to not go out. And so you can see here, it can be used as cancer drugs, because when cancers grow, they need a lot of nutrients and oxygen, and this integrin here causes the cancer cells to not have the nutrients and oxygen, and then slowly die. So it could be used as a cancer drug. And the mechanism behind it is integrin is a transmembrane receptor between metatator cells and extracellular matrix. When tumor cells proliferate, integrins induce signs to promote proliferation of vascular endothelial cells and adenocytes, allowing cancer cells to acquire oxygen and nutrients, which accelerate its growth and metastasis. And here are some clinical applications of snake venom drugs. One is Captopril. It is used to cure diabetes and heart problems. And these 2 both inhibit platelet aggregation, which I mentioned was from the hydrogen snake, because those inhibit platelet aggregation. And these can be used to cure strokes and let the blood flow easily through. And my conclusion, I believe that the Taiwanese snake venom industry has done great accomplishments and is recognized in the world. And I believe that whether it's in the past or in the future, Taiwan sees it as a treasure and has done great accomplishments. And when we say Taiwanese medical research, Taiwan snake venom stands a big part in it. So I believe that this can be still used in the future and have great accomplishments in the afterwards. And thank you for listening.